Okay, today is June 14th, 2011. Question 7 from the review has been taken out. So we're on question 8 right now. So the question says, for the function y is equal to 4 sine bracket x plus 90 degrees minus 3, what is the period amplitude and how far along the x-axis has the wave moved from the equation y equals sine x? So they're talking about a shift from the original one. You guys remember, just like in a parabola, this is our A. Think of this as our H. And this is our K. Okay. If you guys remember, A deals with two things. A deals with any reflections. Okay? So if it is negative, it reflects. And it also deals with stretching the wave. If A is greater than 1, it'll stretch. And if A is between 0 and 1, it'll compress. If you guys notice, this has stretched by a factor of 4. When you stretch a wave, that's going to affect the amplitude of the wave. What is the amplitude of the normal wave? This one here. 1. Technically, there's a 1 in front of that sign. The amplitude is a 1. So, since the A's changed to 4, what is the new amplitude of this wave? That's right. The amplitude is the exact number that is our A. So our amplitude is now 4 on this wave. So we've checked the amplitude. Period. Do any of the things we've learned about H, A, and K change the period of a function? No, that's right. So, what is the period of this sine wave? I'm glad somebody's got it. The period of a sine wave is always 360. Think of it like drawing a circle. When you go right back to the beginning, it takes 360 degrees. Okay? We didn't learn about anything that changes the period of a sine wave. So we've done period, amplitude, and the question also asks us how far along the x and y axis has the equation moved. That deals with H and K. So first of all, our H, which is plus 90 degrees, deals with movements along the x-axis. So shift on x, what is it, Joe? That's right. Because it's a positive, we go in the negative direction. So we go left 90 degrees. And finally, so shift on the y-axis. What is it again, Joel? Yeah, shift it down 3 units. What did I spell that? D-O-W-N, no, 3 units. Okay, question 9 is very similar to question 8. The only difference is we're not dealing with a sine wave, we're dealing with a parabola. In this question, they've asked us to graph all 4 of these. So we'll do the first one in black, blue, red, and then green, okay? So we're going to do this one in black. This is our origin. And we're going to assume everything is moving up and down by a unit of 1, okay? So x and our y. If you guys remember our original, we normally go over 1, up 1. So I'm going to draw the original, okay? This is an y equals x squared without any shifts. Over 2, up 4. 1, 2, 3, 4. So this is our normal graph. Okay, so that's our normal one. So we'll do the second part in red. So if you notice, our H is positive 2. What that means is we're going to go in the negative direction because H is always flipped 2 units. So we go over 1, 2. And then our K is negative 3. So from there we go down 1, 2, 3. This is the vertex of our new parabola. Our A is still 1. So it's still over 1, up 1. Over 2, up 4. And it just continues like that. So this is our A. Our red is the A of this equation. So I've already drawn the original. On the second question, I'm just going to do it in red, B, our h is positive 3. So I'm going to go left 1, 2, 3 in the negative direction. We always do opposite with h. And our k is negative 2. I go down 1, 2. The parabola is very similar to before. The only difference is the vertex is at a different spot. If you notice, the vertex here is at negative 3 and 2. The vertex over here is at negative 2 and negative 3. That's a 3. Okay? Negative 3, negative 2, negative 2, negative 3. Our vertexes change between those two. Question C. Same idea. We start at the origin. As h is negative 2, so I go to the right 2 units. And then k is negative 3, 1, 2, 3 downwards. Here's our new vertex. When you draw these, you can't just draw the vertex. You need to actually draw the function or the entire wave. Sorry, parabola, not wave. No, sorry, wave. So, difference here is our vertex is at positive 2, negative 3. And finally, our D. H is negative 3, so we go over 1, 2, 3, and down 2 units, 1, 2. So here's our new vertex. This vertex is at positive 3, negative 2. So the actual parabola hasn't been stretched or compressed at all. All it is the vertex is moved 4 different ways. Okay, part B, short answers. So it says determine the domain and range of this function. So look again, this is an x and it's squared, so we're dealing with a parabola. If it's not a sine wave, we're dealing with some parabola. This parabola has been shifted left, it's been shifted downward, it's been compressed. But do any of those affect the domain of the parabola? No, the domain of the parabola is still going to stay the same. It's going to go on forever, so x is a set of all real numbers. The domain doesn't change at all. None of the things we learned about of our parabola with our shifts and our stretches change the domain. Now the range of this is going to change. Which of these 3 changes the range, Patrick? The 5, yes. So our k is what's important. Okay, that's changing the vertex and if the parabola opens upwards or downwards. This is negative, so which way is the parabola open? Downward. So it's going to have a what? Maximum. So we have a maximum, and we know that our range is going to start with y, it's a set of all real numbers, and it's just going to have a limitation. We know it's a max, so y is going to be less than and equal to, and what is that number, Patrick? 5. 5 is where the new vertex is. It's the y coordinate of the vertex. The y-coordinate of the vertex is going to tell us what our parabola is going to be less than. So because it is positive 5, you notice our vertex is negative 2 and positive 5. Because it's positive 5, y is less than and equal to positive 5. That's what affects our range. So only if the reflex goes up or down and the k value are the only 2 things that are going to affect the range of our parabola. Okay, question 2 of part B. Write the function in vertex form. In other words, we need to complete the square. So, completing the square, an important question here. First off, when we complete the square, I need to make sure inside the brackets I'm only dealing with x squared. So I'm going to take a common factor out of the first 2 terms. I'm not going to take the x out, because I need to create a perfect square trinomial. I'm just going to take out whatever the coefficient is in front of the x. So because there's a negative 4 in front of the x, I'm going to take the common factor of negative 4 out, x squared. It's going to turn this into negative 4x minus 5. Okay? So now that I've taken out the common factor, remember this is where we deal with our b. I need to take that number and put it into the equation. We had a small equation here, b divided by 2 squared. Okay? Since our b is 4, we substitute 4 in. Okay. 4 divided by 2 is 2, and 2 squared is 4. So the number that we need to add and subtract, so remember we're going to add and subtract this number into the brackets, is 4. So our next line is going to read y is equal to negative 4, x squared minus 4x, then minus 4, plus 4 minus 4. Do minus 4 second. Subtract 5. Now remember, I'm trying to make a perfect square trinomial, so really I only need this positive 4, and I need to bring that negative 4 outside of the brackets. But when I bring it outside of the brackets, it needs to be multiplied by the term in front of the brackets, which is our negative 4. So I have to multiply by that term. So y is equal to negative 4, x squared minus 4x plus 4. And when I bring the negative 4 out, negative 4 times negative 4 is positive 16. Okay? Now our brackets can be simplified. Find the square root of the first term and the last term and bring down the middle sign. Okay? It's a perfect square trinomial. So y is equal to negative 4. Square root of x squared is x. Square root of 4 is 2. The negative sign is there, so I'm going to put a negative sign. And I put a square on the outside of the brackets. All I did is essentially I factored these brackets, and it ended up being two brackets that were the exact same. And that's what we were trying to make in the process. And yeah, finally, plus 11. And that is your vertex form. We have our A, H, and K, if you notice. We're in vertex form. So we changed standard form to vertex form. Find the discriminant. Anyone remember the formula? Don't remember what the discriminant is, right? The discriminant is asking you how many times, it is a number that tells you how many times a parabola crosses the x-axis. So, say we have this. We use a part of the quadratic formula to figure out if it has no intercepts, one intercept, or two intercepts. Depending on what the discriminant is, did you say that, Christian? Yeah, part of the quadratic formula. The discriminant will be a number. Let's see if anyone remembers. If the discriminant is positive, it has two intercepts. Good. If it is negative, it has 0 intercepts. And what's the other option? If it is 0, what do you mean for that to happen? It has 1 intercept. Okay? So, if you guys remember quadratic formula, x equals negative b plus or minus the root of b squared minus 4ac divided by 2. Now that's your quadratic formula. The discriminant is technically just that there. Okay? It's just the b squared minus 4ac, not the square root part. So the discriminant is b squared minus 4ac. You're going to plug a, b, and c into that formula and figure out positive, negative, or 0. So, let's plug in some numbers. If b is negative 4, so I have negative 4 squared minus 4. A is 5, and c is negative 8. Negative 4 squared is 16. 4 times 5 is 20. Times negative 8 is 180. Sorry, 160. What did I say, 180? Negative 160. Okay? So we have a negative and a negative. 16 plus 160 176. So, this number is not important. What's important is, well, technically it is, but I should have said that. Scratch what I just said. Because if it's 0, it's important. It is a positive number. How many intercepts does this have? Yes. So find the discriminant. The discriminant is 176. That's what that's talking about, that specific number. How many times is it across the x-axis? Twice. It crosses the x-axis. Question 4. Factor. Hopefully you guys remember this stuff. Find the factors of the first term and the last term. The product's got to add up to the middle term. Am I able to do it? It's not working. So what do I have to do now? Good. So I couldn't use our factoring, so I'm going to use our quadratic formula. Let's put the A up there. Okay. And we're going to plug our numbers in. So our B is -4. So I have -4 plus or minus the root of -4 squared minus 4 times 2 times -3 divided by 2 times 2. Okay? Negative and -4 will be +4. -4 squared is 16. -4 times 2 is -8. -8 times -3 is +24. And 2 times 2 is 4. Let's go back up here. 4 equals 4 plus or minus the root of 16 plus 24 is 40 divided by 4. Okay. Now this, and we got to find the square root of 40. Okay, so we rounded the square root of 40 to 6.32. Now, this is what's important. Remember, we have plus or minus, so we're getting 2 numbers. And I just want to bring this back to the discriminant. You notice this was a positive number, so it gave us 2 answers, and that's why it crosses twice. If it was 0, this would be canceled out, and plus or minus 0 is not going to change anything, so I'd only have 1 answer. And if this was negative, can I find the square root of a negative? That's why it has no x-intercept. That's the idea of how many times it crosses the x-axis. So finally, we separate this. 4 plus 6.32 divided by 4, and 4 minus 6.32 divided by 4 becomes 10.32 divided by 4, negative 2.32 divided by 4, what's the first one mean? 2.58. Okay, so our 2 x-intercepts, if we were to put it on a graph, one is positive 2.58, the other one's negative 0.58. So we have a parabola. Is it positive? Yeah, it is. So we have some parabola that crosses the x-axis at those 2 points. Those would be our 2 x values. Okay, find that. And round to 2 decimal places. So I have this angle and an opposite side. So we have the opposite side, and I'm looking for the adjacent side, and I have measurement of this angle. Okay? Now, I would assume this is a right angle triangle. Hold on 1 sec. On your exam, now that I think about it, if this is not here, come ask me if it's right angle or not, okay? I will let you know. Okay. So, In this question, this is a right angle triangle. Just things seem to come out that way, I'm sure. So, we have opposite and adjacent sides, which means we're using tangent ratio. So tangent theta is equal to opposite over adjacent. We have the angle, which is 50 degrees. The opposite side is 3, and the adjacent side is x. Remember, I told you there's a quick trick to isolate x. Just switch tan 50 and x. So x is equal to 3 divided by tan 50. All we did was switch those two. X is equal to 3 divided by tan 50. Who's got a calculator? So x is, when 3 divided by tan 50 is roughly 2.5. Am I giving you calculators? You sure won't.
On the day of the exam, most of the people will be right.
Okay. This question says to write an equation of a sine curve with an amplitude of 3, a horizontal translation of 180 to the right, and a vertical translation 2 units down. So our normal one is y equals sine, and we have our A, H, and K. Now remember I told you your amplitude is affected by your A, and whatever A is your new amplitude. So, to start off, y is equal to, we know our amplitude is going to be 3, because they told us it has an amplitude of 3. It doesn't say anything about reflecting, so we know it's going to be positive. It says there's a horizontal translation to the right. So if it's to the right in the positive direction, we're putting a negative sign, 180 degrees. And finally, a vertical translation down 2 units, so negative 2. That's your new equation. I'm just going to write it all in black. Y equals 3 sine x subtract 180 minus 2. Okay. Last 2 questions. According to BEDMAS, we always do inside the brackets first. So the first one is a multiplication of 2 bases that have the same exponent. So all we have to do is use the same base and add the exponent. In this one, it's a power of a power, so we'll be multiplying the exponent. So I'm going to rewrite the next line. So we have A3 plus 5 divided by A5 times 3, and all to the power of negative 1. Becomes A8 over A to the power of 15. Now, because it's to the power of negative 1, what happens to our fraction? We want to make it positive. Anyone know? Flip it. So we're going to flip this. It then becomes A to the power of 15 over A8. So that's positive 1. Now, if it's positive 1, do I need to write it in? No, it's not important anymore. It's not going to change anything. So A to the power of 15 divided by A to the power of 8. We're dividing 2 bases that are the same, so we can just rewrite the base, subtract the 2 exponents, A to the power of 7. That's a simplified version of this. And finally, write as a radical and evaluate. The radical means like a square root type question. If we have a fraction, what that means is the bottom or the denominator of the fraction is giving us what root we have to put the question to. So this one's a 3, so I need to put it to the 3rd root of 8, and I keep the power of 4 on the outside. So that's the radical part. That would be 1 mark right there. Evaluate is the second part. 3rd root of 8, what number multiplied by itself 3 times makes 8? 2. So 3rd root of 8 is 2 to the power of 4. And 2 to the power of 4? 60. So now, you got it. How would you get that? For this root, we know that 2 times 2 times 2 is 8. 2 times 2 is 4. Times 2 again is 8. And 2 to the power 4 is 2 by 2 by 2 by 2. And you multiply that, you get 16. So there's our evaluated number.